master course. In this session, we are not going to write any code. Instead, we are going to build a simple, clear mental model of what's going on behind the scenes. So especially what is AI, what is generative AI, what large language models are, and what makes an AI agent different from a normal chatbot, chat GPT, like chatbots. So before we dive into, I just want to give a quick introduction about myself. I've been working on AI and AI agents, building AI agents for last 1 years. I learned AI agents by doing it. I've gone through hundreds of blog posts, tutorials, copied the code, and gone through each and lines of code and understand how it works. That's why I just wanted to teach you about the way I learned about how agent works, writing the tools, how we can debug it, how these agents break, where they will actually excel well. So all those things, we're gonna talk about this tutorial. So I know it will be kind of overwhelming. You probably heard about a lot of buzzwords already, like generative AI, LLMs, agents, copilot, co-work, cloud code, hooks, orchestrator, and whatnot. So it can feel like constant of new terms coming into your mind, and it is very easy to get lost. Easy to get lost. The constant way of information. So day one is here to fix that. My job is to do slow down everything and build a bigger picture about what is AI agents. So we outline what each of these words are points to on how they connect about AI, generative AI, large language model, and finally AI agents. So think of today as a foundation layer. Before after this we will get into practical. We will be using LangChain and we will be setting up the local Gemma model, and we'll be running model tools in the local machine to show how agents works. So if you understand the big picture today, the everything we will build upon, which will be much more natural. So day one, just relax and listen and focus on the concept. As we go, imagine how you would explain to a friend who is curious about AI but overwhelmed by the buzzwords. I always like Richard Feynman. I just wanted to quote his famous quote: "If you want to master something, teach it." So that's one of the reason I want to teach that AI agent. Even though I know how agent works, I want to be a master. That's why I'm teaching it. By the end of the course, I expect everyone to be a master. Stickers will be initiated by machine powered by AI. So in plain language, instead of people calling support desk or clicking the buttons, agent will talk to other systems on behalf of us, and they will get the things automatically without you don't even to code. Next, think about AI agents as a digital assistants. So leaders in tech, they see AI agents not just as chatbots, but as a navigator for the complexity of modern life, handling loads of information, coordinating tasks, and surfacing the right action at the right time instead of us doing everything manually. So experts expect AI agents to manage more and more of routine work in our lives. So everything from our scheduling and reminders to finance and operations to keeping different apps and services in sync. AI agents will become the connective tissue between us and the systems we use, because all the days we do a lot of manual tasks, even though we have AI available, but we do all the tasks because these AI cannot connect. So that's why AI agent comes in picture. So when you talk about learning AI agents in this course, it's not something like a niche skill. It's going to be fundamental shift. That's going to be core of in the coming wave. So we are learning this technology that is expected to sit in the middle of the customer service. So going forward, all the customer service automation and all the productivity related application, everything there will be AI agents will be working on the background. So keep this slide in mind. If you go deeper, every tool, every line of code, every small demo is a piece of the largest shift towards AI driven agents handling real work for us. When you say AI is not a new term, if you look at our day-to-day world, AI is already around you, right? So if you open a Netflix app, on the front screen you see, the recommended movies or shows, which based upon the AI model, the working in the background, learn from your patterns, the movies you watched. From that, information, it suggests what is the next movie you can watch, or what is the next show you can watch. Then similarly, if you go to YouTube, once you go to the home page, based upon your watch history, it just recommends what are the others, YouTube videos, shorts, you can watch. Similarly, Instagram, every social media platform they use AI. On Spotify, it uses a predictive model for music and music suggestions. It can create a playlist of basically the songs you listen so far. And in the security, probably we all use Gmail, so most of us use Gmail. Gmail, if you look at this smart filtering, it actually, there is a models behind it, actually goes through the humongous task of reading every email and deciding which is a spam or not spam, right? So there is a model actually running in the background. We all use Google Maps and Apple Maps. The maps actually suggest you, like, if you take this route, this is the shorter ways to reach it. And how does it work? How does it work? Because there's a model running in behind. It actually, based upon the previous patterns, traffic congestion alerts and all those things, it just predict, if you go by this route, it will be much faster. There is a delay, if you take the other route. These are all AI behind it. So without even knowing the word AI, our AI is integral part of in our life. So people talk about, I know everybody confused about AI, machine learning, deep learning, generative learning, generative AI. I just want to take a pause and explain this concept before we go into deeper. So when computers try to do things automatically, like what human thinks, that can be termed as AI. AI is an umbrella term. So anything computer does it, what human can do it, that can be termed as AI. So for example, if your smartphones, Face ID unlocking, that is the AI model behind it. So the computers playing chess with humans, and the YouTube algorithm, which actually suggest you the next video. These are all considered as AI. And then what is machine learning? So machine learning is a way to build AI where the computer learns from the examples instead of being given every rule. In a traditional programming world, you actually write a rule. For example, if the condition A meets, then go to B. If the B meets, do something. You see that's how you manually codify every rule. But machine learning actually it takes an action, based up it from the examples. It actually, from the training sample, it actually learn and find a rule, and then it does the action based upon the learning, right? So for an example, you want to build a machine learning model, just to find out what is cat, or which image is cat, which image is dog. So you train the model with thousands of dogs and cats images. So what happens, the algorithm actually look for the patterns, if it is a dog, how the ear looks like, how the nose shape is, what the fur, and it has got tails, all this information. It learns, every piece of information based upon the data, we feed it. How the human learns it, right? So when we are younger, we actually see things, like for example, if you see a car, how do you recognize car? Because we've been learning that different cars every day and see and pattern match. If you see the car, okay, this is a car. So that's the same way, there's a machine learning algorithm model. They learn based upon the training samples. So what is deep learning? So deep learning is a special type of machine learning, which actually you can consider it as a deep, the systems connected by the brain, right? It's a network of layers connected in order to do the complex task. It's easy to you can distinguish between a cat or dog, because this is a simple model. So what if you are building a self-learning car? How does the car identify there's the human crossing, there's a traffic light? So how because this actually needs the complex set of layers to go into each and every level of detail, identify the images, and every layer actually images and speech and languages. So example, the voice assistant understanding what you say, right? Nowadays, and apps that can describe what is in the photo. If you upload a photo, the photo says these are the objects in the photo, the self-driving cars. So you consider it's a deep learning is a very big layered machine learning model that are good at hard tasks, like complex tasks like image recognition, speech recognition. So just to give a small example, you consider A as a big school, like A is a big school. Machine learning is like, you're learning a science subject in a school. Deep learning is like one of the advanced science subject within the science. For example, you can say theoretical physics, right? So that's how I'll just explain AMLDL. Let's move on to the generative language. We all talked about AI, deep learning, machine learning. What is generative AI? So all these days, these models and everything, it actually recognizes. It just it does the speech recognition, it does the voice recognition. Can it generate any new content out of it? That's where the generative AI comes in picture. It based upon the rules, based on the prompt, it can generate a new content for you. So traditional AI mostly follow some rules, like if there is a traffic light image, it's a traffic light. The person moving, it is a person. So those are it just work on a certain set of rules. But generative AI is completely different. You can create a new content for us that is didn't exist before. So you can ask, you can just there's how do you give instruction? The instruction called prompt. So you can give a prompt to the ChatGPT, draft a friendly email to my team. It just generate the friendly email for you. And if you want to actually generate an image, create an illustration of a robo on Mars, and the model generate brand new output from the scratch based on the pattern it has learned. How does it do? Because underlying generative AI, there is a large language model. It's actually trained billions of web pages information fed into that model. That model actually learned all these patterns, images, text from that, right? So based upon the learn, like a chatbot can draft email instead of you writing every sentence. The generative model proposes what is the next sequence of email based upon your tone. And tool generating, I'm sure everybody use Nano Banana and Gemini and all the image generation tool. Based upon the prompt you were given, that it can generate a new image from scratch. So we talked about generative AI. The brain is large language model, so the engine. So you can think of what is this engine. So you can think of LLM is an supercharged version of autocorrect. So given, for example, you given some words, the cat sit on the, and what is the next word, it actually predicts based upon the pattern you learn. Because so cat sat on the wall, it is very common. So cat sat on the board, there's another option. So what is closely related? Because cat sat on the wall is very common. That's how it predicts the next word, right? And the scale, the model, large language model, it actually can scale. It got billions of setting, it got temperature, top heat, top K, all those things we'll discuss in later part of the course. I just wanted to focus on this one because of this this scaling, this internal setting, it can capture many patterns in language, and it can explain complex topics. So it can help us to debug the code, and it can also generate the long documents. And this comes to the limit. I know large language model LLMs can generate a text, it can summarize, it can generate images, but there are limitations to that, because the reason is that all the large language models are trained based upon the certain data, right? Certain time data. It's not up to date every day. Some models get updated. If you ask any real time information, like who won today's World Cup match, it can sometimes it hallucinates. Until unless the model doesn't have the data, it will hallucinate. and that's why we need to model can also make a mistake because it's predict based upon the previous data. Sometimes it may hallucinate if it doesn't have any data, it just try to say some random word. So and also it sounds very confident that even though it is wrong. So we need to build up a guardrails and governance, and this will be human judgment also in the loop. So when we build the AI agents, these LLMs will be the brain. So that is a language used for generating the languages and does the reasoning, and the rest of the agent systems provides tools. So consider agent has got large language model, it has got tools and memory. Those are the building blocks, which we'll discuss in the next next slides. We talked about LLM. So LLM, you consider it as like a chatbot. So if we ask something, it will respond back to something based on the data it learned in the past. But you can't, if you ask LLM to book a flight ticket, you can't book because it doesn't have any tools to connect to that. You're calling the flight booking providers API. If you ask to check the weather, it doesn't have any APIs connects to that weather information. So if you ask LLM to cancel subscription, it can't log into your bank account. It doesn't have access to your internal company databases, and most over it often forget the past context. If you open a new chat, it actually is not every LLM. Some LLMs forget all the context which you talked about in the past. So that's why agent comes in the picture. Agent can actually invoke some tools, and it can have a memory. It can actually store the previous context. It can take an action. So which we will discuss in the next slide. So we talked about LLM as a chatbot. If you want to perform some task, you need an agent. So just think of agent is here to achieve a certain goals. AI agent is more than a chatbot that not only talks, it actually takes steps to reach a specific objective. So a basic chatbot can explain what a generative AI. It actually create all the you can explain step by step, but it can't actually search flights for you. It can give us information about these other flights available, how to book it, but it won't actually book for you. That's why it comes in picture. So a agent can search for a flights, it can pick an option, and based upon your rules, it can go and complete the booking for on behalf of you. So agent not only information retrieval, it will be actually fulfilling your goal. So if you look at the basic architecture of agents, it has got LLM, that is a backbone which will be used for planning and reasoning, and there's an action taken based upon the tools is connected. If a tool connected to invoke the flight center flight API, those are the tools, and it stores all the past context of like what you're discussing the so far. That's why it based upon your user preferences, it takes some actions. And there's a set of system prompts, like if you want to this agent is specific for something, you can put also the guardrail, and the system prompts you can put it in the prompt template. This is as a basic idea about what is AI agents. So so we talked about again I just wanted to stress out that the three pillars of AI agents is first is tool usage. It can actually agents can call external APIs for like if others booking the flights and databases. It does store memory of all your past conversation. It actually maintain the context of what action needs to be done the next planning. It does the planning. For example, you give an option to based upon I want to book a flight, can you book a flight trip for me in New York. It actually goes and it actually take that task into each individual steps, and every steps it actually does it sequentially. For example, do for the flight search, do for the booking, and check the weather in New York, and book a hotel in New York. All those things it can do the planning as well. So that's the beauty of agents. The normal LLM cannot do. That's why to fill the gap of the task fulfillment, that's why agents comes in the picture. So we talked about AI agents, and I know everybody we keep hearing about LangChain, Google ADK, CrewAI, AutoGen, all those things. These are agent frameworks. So what do we need an agent framework? So building agents like from scratch is like building an entire smartphone for yourself. You can't actually design a screen, battery, and all the apps and operating system, all those things. Yes, it can be possible, but sometimes it is slow, painful, and things will break. That's why this agent framework comes with a toolkit. It does provide the layers of how to manage memory of context memory, what are the tools you need to connect, how to connect to the internet APIs if you want to call, what are the workflow steps you needed. These are the tools comes with the agent framework, and this also gives a provision to agents to talk to API and other services and work with the multiple models. For example, you want to call different models, Cloud or OpenAI or Vertex. That agents will these frameworks actually facilitate those calls, and it also helps you to debugging and monitoring and safety of the agents. If you're building agents supposed to do what's supposed to do. If it is trying to do something other than supposed to do, these frameworks actually stops them doing it. It got all the guardrails built in around it, and it also identify the if the agents make mistake, it actually correct those mistakes as well. So some of the popular framework: LangChain, OpenAI SDK, Google ADK, and AutoGen. Amazon has got their one. It's called Standards and CrewAI and Semantic Kernel. So we talked about orchestration frameworks. So the LangChain helps developer connect LLM to data, and if you want to invoke an API, you don't need to build all the code from scratch. So this LangChain framework comes with all the predefined code. You don't need to write all those code from scratch, and it provides a secure access. If the agent needs to talk to the external tools, it actually helps us to securely talk to those agents, and it manages the permissions and how the data flow needs to be traversed. Everything agents manages. And the most important part is the modularity, right? Today, you set up a LangChain to connect to Cloud, and you see that the output is not working because for certain use cases you want to use the Vertex A, so that you don't need to do any code. That's the beauty of LangChain. You can connect to a different model, Vertex A, and then OpenAI. So that modularity will be taken care by LangChain framework. The last I wanted to focus on local models and data privacy. So in this tutorial, I don't want to build. Yes, we can build an agents, consuming the models running in cloud, cloud models, but it requires some cost towards it, and also privacy. Your data will be sent to the over the cloud, and if you're too paranoid about your security and you want to start something which you don't need to spend much time, much cost, then the option is building a Ollama. Ollama has got all the open source models available. You can download Ollama and you can host the large language models into the Ollama model running it. It will be running in your local machine. It can be a Windows, it can be a Mac, and you can use the LangChain to talk to this LLM model. For in our example, I'm going to use a Gemma, so it can cause to Gemma for planning and reasoning. It can take the action toward this. The demo use case, what you're going to build, we're going to build a birthday party planner. So this agent is going to find a venue for birthday party, and it suggests you themes. It actually book a menu for what is your budget, all those things. But remember, if this is running on local, this will be all the fake data. But I will also try to show that how it can connect to the Google APIs to find the real data as well. So hope we have covered all the basics needed for the building AI agents. In the coming days, we will be focusing on how to set up the local agents, local Llama model, how to get the open source model running in, how we can set up the developer environment, how we can create a LangChain based agents in the coming lecture. Can't wait to build the agents. Thank you. If you have any questions, if you see, something, if I done any mistakes, please correct me. Please post your comments. This is my first video course. Hope your feedback will help me to fix my mistake, so that I want to help you everyone to become a AI agent developer. Thank you.